Okay, let's try number 11 here. So for number 11, we have somebody here inside this special work vehicle, and he's looking up at the top of his rig here. So we have that angle of elevation again. We're gonna go ahead and draw ourselves on that angle, or we can just put ourselves in here, right? So if we're standing on that angle, we wanna go ahead and label our sides. And again, I just always do this out of habit, always write down SOHCAHTOA. It's always good to have a visual. All right, so we have SOHCAHTOA there. We have our trig functions because we have a right triangle. I'm going to label the sides in relation to where I'm standing. So opposite side and my adjacent side. So if it's opposite and adjacent, it means I'm going to use tangent. So I would use the tangent of 45 is equal to opposite, which is 60, over x. Now this is one of those kind of funny ones where the x is in the denominator. When you have the variable in the denominator, remember we're going to swap these. They're going to swap places. So we'll have x is equal to tangent of 45. I'm sorry. Is equal to 60 over tangent of 45. And we can go ahead and plug that straight into the calculator. So we would do alpha y equals to get our fraction, and then 60 over tangent of 45. And that would give me that would give me 60. So the tangent of 60 over the 60 divided by tangent of 45 is going to equal 60. And when we look at this, do you see how this is a 45-degree angle? If we know that there's 180 degrees in a triangle, and this is 90 and this is 45, that means that this other angle has to be 45. And we know that a 45, 45, 90 triangle, the legs are congruent. So if I know that this is 60 feet, I'm automatically going to know that x down here is 60 feet as well. So you can use that shortcut. You can always use special right triangle shortcuts. If you forget, that's okay though, because you can always use sine, cosine, and tangent. You can always find it that way too. So the shortcut way is easy, but if all else fails, just go ahead and use our trig functions here. So let's look at number 12, our last pretty picture up here. Again, we have an angle of elevation. We're looking up from the boat to the plane up here. So that's an angle of elevation. I'm going to go ahead and draw myself on the boat here. I don't get out on boats very much, but they are a lot of fun. All right, so I'm going to label the sides in relation to me. I have an opposite side and I have an adjacent side. So again, we're going to use tangent. So I'm going to write tangent of the angle I'm standing on is equal to opposite over adjacent, so x over 75. Okay, now we're just going to multiply by that 75 to get it out of our denominator. Do that to both sides. Those cancel out. And so that plane, we're trying to figure out how high up in the air it is. If I do 75 times the tangent of 25, in close parentheses, it's about 34, actually would say about 35 yards in the air, because we would round that to the nearest tenth, right? So if we round that up, that's going to bump our 9 up, and we would get 35. Okay, so 35 yards up in the air for that plane. All right, so here's where it gets a little bit more complicated, not too much. We just gotta draw some pictures, okay? So it doesn't matter if you're the best artist, but it is a good idea to set up pictures for all of these so that we know what we're looking at. So first off, it says we have a tree 40 feet high that casts a shadow 58 feet long. Find the measure of the angle of elevation of the sun. Round your answer to the nearest degree. So first off, we have this tree here, right? We have this tree, big and tall, and it's casting, oh wait, we know that it's 40 feet, so I can go ahead and label that. My tree, I'll write it over here, my tree is 40 feet. And it's casting a shadow that's 58 feet on the ground, right? So 58 feet. And we want to know what is the angle of elevation, right, to the sun. So if we have this angle of elevation up here, we're trying to figure out how high the sun is up here that casts that shadow, right? So what is that angle of elevation right here? So that tree and the ground form a right angle, right? So here we have a right triangle. So we have 2 sides out of the 3. And we're looking for an angle. So we're going to use an inverse function here. Remember, anytime we're looking for an angle for a right triangle, we're going to use inverse trig functions. So again, if I look up here at my trig functions, I want to label my sides. So if this is us down here at angle X, the side across from me is my opposite, and the side next to me is my adjacent. So I'm going to use tangent, okay? So the inverse tangent, or tan to the -1, of X is going to be equal to my opposite side over my adjacent side. So 40 over 58. So I'm just going to take my handy dandy calculator here. Second tangent to get that inverse function, I'll put my fraction in, and then it's just 40 over 58. So it looks like my angle of elevation is about 35 degrees. So it's about a 35-degree angle from where that shadow is hitting, looking up to the sun. Okay? Let's try our number 14. Number 14, we have an angle of depression here. Okay? So let's take a look at that one. So the angle of depression from the top of a tower to a spot on the ground 30 feet away from the center of the base of the tower is 52 degrees. Find the height. Okay, so it says an angle of depression from the top of the tower looking down 30 feet away. So if we're looking down here, and it's 30 feet away from the center of the building, right? So 30 feet. We know that that angle of depression is 52 degrees. So what this means is when I'm looking down, right? When I'm looking down here, it's 52 degrees down. What's really interesting about this, though, is that when you have an angle of depression, if I'm looking down, it's 52 degrees. That means that it's the same angle down here because these are parallel lines. The horizontal line of sight and the horizontal at the bottom, those are parallel. And we know that alternate interior angles are congruent. We learned that earlier in the school year. So if this is 52 degrees, that means this angle down here is also 52 degrees. So now I have an angle, I have a side, and we're trying to figure out what is the height of the tower. So the height of the tower is going to go right through here and make a right angle. Okay? So now we can use our trig functions and the fact that this is an angle of depression, and we know that angle now. Now we can use our trig functions and solve for that missing piece here of my height. Okay, so let's go ahead and draw ourselves on the ground here. And we're going to label the sides in relation to us. So this is my opposite side. This is my adjacent side. You see a lot of tangent when you're looking at angles of elevation and depression. It just kind of happens. So we're going to do tangent of the angle I'm standing on, which is 52 degrees, is equal to my opposite side, which is x, over 30, which is my adjacent side. And we're going to multiply by 30 on both sides to get rid of that denominator. And then we'll just use the calculator to figure out what 30 times the tangent of 52 is. And it comes out to be about 38.4. So it's about 38.4 feet tall.